Okay, this is a quick video demo on this KPS3102 Serial Communication Serial Device Server, okay, transparent mode, okay, for using TCP IP client. Okay, let me let me explain what is that. Okay, so one let me take this as a scenario whereby we have this serial communication device. For example, it could be a barcode. Okay, so you may want to connect this serial communication directly to the IPC. Okay, but sometimes it's too far away, so we need to have this KPS 3102 to be there, so that no, so that we can have a longer distance. Or there's the opportunity that you may have multiple or you have multiple barcode scanner or device whereby your IPC probably only support up to two RS232 port. So you can just keep on duplicate. Yeah. So this is but for today's example, okay. I'm going to do it. I'm going to demo only one KPS3102. Okay, so but today I have a problem because I don't have the barcode scanner with me. So the strategy to do this demo is instead of having two serial communication this serial communication barcode scanner, what I'm going to do is I'm going to look bit back to my IPC serial communication port, which is called COM port 1 and COM port 2. Okay, again, because I lack of material, okay, I will be using a RS485 for port number 2. Okay, but for here is RS232 because there's a converter. So port 1 of the serial device server serial device server will be RS232 followed by RS485. Okay, maybe later we will try to see if we can uh, do some do some stuff. Okay, so the IP address for this is at the default setting of 192.168.0.249. Okay, my PC will be 192.168.0.13. Okay, notice this is the schematic drawing of the drawing of my testing today. So I'm going to open up a flame sensor, okay, at COM1. Okay, reach out to port 1 of this KPS. Oh, sorry, I spelled wrongly. Then it will convert this string or this frame, okay, to here. Then this packet will go to this designated IP, okay, and it will go to the port number of 1001. Okay, so COM port 1 will be the packet will be sent to 1001. Okay, COM port 2, okay, will be sending to 1002. Okay, so now I will do the demo. Okay, okay, so I reach out to my IPC now. This is the IPC. Okay, so and I type the IP address of 192.168.0.2, like 249. Okay, so and the admin and the password is admin also. Okay, okay, so for good practice, usually I do a reset. Okay, I will perform reset to default. Okay, so everything now is going to be default. Okay, okay, so the next thing I want to do now is I reach out to let me see if the reset is okay now. Okay, 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 maybe I can squeeze this to here so that we can have a better understand. We can see this better. Okay, let me see if I can put it over here while we are waiting for the thing to. Okay, good. Okay, so let's try again. Okay, it may take some time to reboot. Okay, let me choose to put here. See if picture look better. Okay, good. Okay, let's try again. 192.168.0.249. Okay, I think I know the problem. Somehow during my factory reset, I observe there's an alarm. Okay, let me push this upward. Okay, somehow there's an alarm. I don't know why. Okay, but now the alarm went away. Okay, good thing that it detect alarm and it went away by itself. Okay, let's try again, see if I can log in now. Okay, good. Now I can log in. So let's log in. Let us log in. Okay. So now go to the serial interface. Okay, first this is serial port 1, which is the serial port 1 over here. Okay, let's configure this at a baud rate of, okay, the baud rate is 19200 followed by 8-bit, none, and 1. So okay, come to here. Then followed by okay, the first port is RS232, so let's do it RS232. Okay, the network mode, okay, as per mentioned in is transparent mode. Okay, so transparent mode and as a client, okay, client. Okay, and you get to see this. Okay, this is the transparent mode. Okay, earlier we have a lot of video on the Modbus RTU, but now it's transparent mode. So you just leave everything in default. Okay, the next thing we want to do is, let me see if okay, we need to define the target IP address. Okay, so whatever value from port 1 will be diligently go to 192.168.0.13. So this is the 13, how I arrived 13. Okay, target port, I want to reach out to 10001. Okay, so it's 10001. Okay, and that's it. So let's apply, and it should apply. Okay, okay, let me squeeze this a bit to the left again. Okay, okay. So okay, let's go to port number 2. Okay, okay. This now we are defining the same port. Okay, baud rate, but it's at RS485. Let's leave it as default. Transparent mode again. Transparent mode again. Client is a TCP oblique client. Okay, leave everything as the same. Okay, okay. But this round, let's define this as 2. Okay, 2. Okay, and 192, okay, and press apply. Okay, so notice why I arrived this 1002, because whatever frame sent from here will be going to 1002. That is the motive. Okay, so everything seems to be in place. Okay, seems to be in place. Press and okay, so it's everything seems to be in place. Okay, so what I do usually, if I let's try. Okay, let's try now. Okay, so let's create I'm using this PCOM emulator. Okay, to send the frame. Okay, to send the frame. Okay, let me put it over here. Okay, let me create one. Okay, serial communication port. Okay, and it's did I use the correct one? Oh, sorry, not this one. I need to open it over my remote PC, which is this one. Okay, sorry. So it's PC emulator. Okay, PCOM emulator. Okay. So let's create COM port 1, okay, COM port 1 at the baud rate of 19200. You see data, how I arrive this 891 is by setting, okay, because I defined it earlier over here. Yeah, so it's 192.0.0.8 So just make it the same. Okay, this is COM 1, and so this frame generator is actually this frame sender one. Okay, sender. Okay, let's create the second one, which is COM port 2. Okay, let's try COM port 2. COM port 2. Okay, baud rate, everything is the same. So this will be the frame sender. Okay, frame sender for COM 1, COM 2. Okay, now what I'm going to do is I'm going to open up an addition software, the same software emulator. Okay, but this time this is the one connecting to the Ethernet port of the Ethernet port. Okay, let me see if I can get this correct. Okay, good. So let me open up. Okay, it's supposed to be a server. Okay, because I define this as client, so reach out to here is a server. So change this to TCP IP. Okay, because it's a server, let's do this as a server. Okay, but the port, what is the port? So the first port will be 10001 and press enter. Okay, so now it's at the listen stage. Okay, let's create the second port. Okay, which is 10002. Okay, 2. Okay, and you should get to see this. Okay, let's try. let's try. Okay, now it's at. Okay, let's try. Okay, let's try type something here. Maybe I type 1111. Okay, so by right, whatever character that I send from here, it should receive from here. Okay, if I do the same 1111, okay, hey, it's receiving now. Okay, good. So notice the connection is connected. Okay, connected. Okay, so you see, let me try again. This time I press 2222. See, notice there's 2222 over here. Okay, if I press here and press 3333, you get to see this character over here. Okay, likewise, if I press 5555, okay, you get to see 5555, okay, 6666, okay, if I type 6666 over here, you should get 66. So this is a very good indication that it's working now. Okay, it's working now. Okay, back to the barcode scanner function. So when we are doing a barcode scanner, usually it comes with a start of frame and end of frame. Some people call it a header and somebody call it a terminator. Okay, for popular choice of a terminator is usually 9 feet return coverage, which is the ASCII code of I think 0D0A. Okay, let's try this. Okay, let's try this. Right click, send a pattern. Okay, let's send a pattern of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and let's send it at a pattern. Okay, then followed by the return coverage, which is 9 feet, which is 0D0A. Okay, and let's send it at repeat until at the interval of maybe 100 millisecond. Okay, let's try that. So you see, so just imagine this is a simulation of multiple barcode scanning. Not multiple, one barcode scanning. Okay, and this and the other side is receiving now. Okay, let me clear this, clear the screen so that you can see the repeat activity. See, it's at the interval of 100 millisecond. So yeah, so this is the understanding. Okay, so what for COM2? Okay, let's repeat the same. Okay, let's repeat the same. Send a pattern, but instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's change it to maybe alphabet of A, B, C, D, E, F, G, H, I. Okay, I. Sorry, did I misspell? A, B, C, D, E, F, G, H, I, J. Okay, so and let's send it also at a return coverage over here, 9 feet return coverage, and at a hard interval of 100 millisecond. Okay, and wow, we get to see this. See, yeah. So this is two barcode scanner. It's as if simulating a 2 barcode scanner. Firing at the same time at a frequency of 100 millisecond. Okay, so likewise, okay, we can do the same. Okay, we can do the same by firing back. Okay, because barcode for port 1, I'm using RS485 Okay, so it's a full duplex communication. That means I also can fire something over here. Okay, let's fire a pattern. Okay, and let's fire a pattern of maybe 9, 8. Okay, let's try something different. Maybe P. Yeah, something like this. Okay, then followed by 0, D0A. Okay, and let's fire at also at this. Okay, so notice it's firing back. You see this these two is actually firing the same frame. Okay, so it's a full duplex type of transparent mode now. Okay, but because RS485, the physical layer, only support half duplex. So if we do the same thing, there will be chances that two frame will the receive and the sending frame will crash together because they are using the same physical layer. So let's have a try. Let's have a try. Just to negative try on this. Okay. So yeah, let's do the same. Okay, let's do the same. But instead of doing this, let's try a reverse numerical value of 9. Yeah, something like this. Okay, and I send at a interval. Okay, observe. Okay, yeah, it's working fine for RS485. Okay, maybe I'm not clocking at the same frequency. Let's try again. Because my earlier testing is not working. Okay, sorry, it's supposed to be A, B, C, D, E, F, G, H, I, J. Okay, let's try. Yeah, I don't know. For this case, seems to be working fine. Probably because when they are, I can't explain this. Probably because although they are on a physical layer, but coincidentally, between that 100 millisecond, it was not correcting. Okay, so let's have a look. Or it's correcting already, but okay, let's try to stop and try again, so that the starting point will be a conflicting point. Okay, no. Okay, let's try again. Okay, so this is what I'm telling you. Okay, so if it happened to be on the same phase when they are sending and receiving, okay, then it will be in this kind of mess. Okay, because it's running half duplex. So with this, I end my presentation. Thank you.